Hello, grade 11s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Uabudiwa Sos Ukobela Maths. And without any further ado, let's look at this question that we have here. Okay, so we have question 3, still on Newton's second law. It says a 250 Newton force is applied on a block of mass 25 kg. The 25 kg block is connected to a 10 kg block by a light inextensible string through a frictionless pulley, as shown on the diagram below. The 250 Newton force acts at an angle of 25 degrees to the horizontal so that the system of blocks accelerates to the left. Note that we are not told the magnitude of the acceleration. The coefficient of kinetic frictional force between the 25 kg block and the surface is 0.15, right? And then we have our diagram like that. Then 3.1 says define the term kinetic frictional force. We say this is the force that opposes the motion of a moving object relative to the surface. So that's how you are expected to define it according to your CAPS document. Then 3.2 says draw a label-free body diagram of all forces acting on the 25 kg block. So you already know that you have 7 marks for free. So the first 2 marks for your definition, and then the second 5 marks for just drawing your free body diagram and then labeling it. So we do know that the dot represents our object there. And then going downward there, we always have our gravitational force, because every object on planet Earth will experience the gravitational force. Then here we have the normal force, and then to the side, that's where we have our tension, because we can see a rope there or a string. Then going to that direction, we have our tension, our force applied, meant to say. So that's the applied force. And then still in the direction of the tension, remember, this block is accelerating to the left. Therefore, we know that the kinetic frictional force will have to go to the right, since it's opposing the motion of the object, right? So now we have our forces like that, 5 of them for 5 marks, 1, 2, 3, 4, 5. And then that's correct. Then 3.3 says calculate the normal force exerted by the surface on the 25 kg block. Now, to calculate the normal force, let's consider that this is being pulled at an angle, right? So if an object is being pulled at an angle, we know the formula goes as normal force is equals to the Fg minus Fy, right? So this comes from having to resolve here. If you have your Fx like this, and then your Fy going upward since it's being pulled, then that's your Fy. Now, if you have to equate again, this is Fn plus Fy is equals to Fg. If you leave your normal force as the subject of the formula, this is where we derive the formula from. Yes. So, yes, that's Fn is equals to Fg minus Fy, right? And then now to calculate our normal force, let's calculate it quick. That's Fn is equals to mg minus f sine theta. And then our mass is 25. Multiply that by 9.8. Then our force here we are given to be 250. So that's 250 sine 25 degrees, right? Then having to punch all this into your calculator, you have the magnitude of 139.35 newtons, right? So that's your normal force. For 3 marks, you just needed to write the correct formula, substitute, and then get the correct answer. Then 3.3.2 says now calculate the acceleration of the blocks, right? So allow me to just erase this part here so that I can start with that. Now remember here, the trick is you also need to draw the free body diagram for the other object, right? So you've been asked to draw the free body diagram for the 25 kg block, but then drawing the free body diagram for the 10 kg block will also come in handy, because this is a system, right? So it is being pulled upward. So that means my tension needs to be longer than the FG, right? So that means tension is greater than the FG. And then we know our formula becomes T minus FG, right? So, okay, let's start with the 25 kg block. So we'll say for 25 kg block, then which one is our positive direction? Obviously, this has to be the positive direction since we'll be taking left as positive. That's the direction of motion. So it is going to the left. Therefore, let us take left as positive. Then this one will be negative, right? Then that means our equation will now be what? Fx. Remember, we are only considering the horizontal forces. So we can't be using the force applied because it is diagonally. Therefore, we had to resolve first. So that's Fx minus Fk minus the tension is equals to ma. Now, breaking down this, that's F cos theta. So we know Fx is F cos theta. And then this will be, so let's break it down, F cos theta. And then the Fk here, we are not given the value for the frictional force, but instead we are only given the coefficient. So therefore, we need to also break down our Fk as nu k multiplied by n. Since we did calculate the normal force in 3.3.1, then minus our tension, and then ma. Now let's start substituting in here. We have 250 cos 25 degrees minus our mu k is 0.15, and then multiply that by the normal force, which from the previous question we got 139.35, and then say minus t is equals to our mass, remember, is 25 and then 25a, right? Since we don't have the acceleration. Now, when you punch all this into your calculator, you get a value of 205.67 rounded off to 2 decimal places, and then minus t is equals to 25a. Now, you know I always prefer to make the t the subject of the formula, so I will have 205.67 minus 25a is equals to t. So I will call this my equation number 1, right? Okay, now that I have drawn the free body diagram for this one, let me use that. So let me just erase here because I've already used it. Then let's continue and indicate for the 10 kg block. So now let's say for 10 kg block, then this is F net is equals to ma. But then remember, it is being pulled upward, so my equation becomes T minus Fg is equals to ma. The tension is what I don't have, but then my mass is 10 kg and my gravitational acceleration is 9.8. Then this is 10a here. So this will be T is equals to 10a. The 10 times 9.8 gives us 98. If you transpose it to this side, it's positive 98. Right, so I will call this my equation number 2. Now we do understand that at this point, we need to equate the two equations to find our solution. So let me just continue here. Then I will say equate equation 1 and equation number 2. So equate equation 1 and equation 2. Right, so now I have the 205.67 minus 25a is equals to 10a plus 98. Now I will have 205.67 minus 98. If I can transpose the 25 over to this side, that's 10a plus 25a. Now subtracting this, it gives me 107.67. But then here I have 35a. Dividing both sides by 35 since I'm looking for a, then a will be equals to 3.08 meter per second square, right? That's how I found my acceleration for a total of 7 marks. So we can say this one, they were a bit generous with the marks. It was very, very fair, right? But then that's how you could have tackled the question. for a total of 17 marks. So make sure that you play the video as many times as possible and try to understand the approach that I took in solving this question. But then with all that being said, please press the thumbs up button if you have enjoyed the lesson and then you have found it helpful. And then if you've been watching the videos and haven't subscribed yet, please hit that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.